All right, like I said, these are kind of long in terms of pages of notes, but a lot of this we've already talked about. This is a really fancy definition for a polynomial. Basically, it's the A's are just the leading the coefficients, okay? And the X's are showing that you could decrease in powers, but they have to be real numbers. They can't be, it says n can't be negative and it can't be rational numbers, it has to be integers. In other words, you have something like this, an x to the fourth minus 2x squared minus x plus 7. That's a polynomial, okay? The powers up here cannot be fractions or decimals or negative numbers or anything crazy like that. When you graph a polynomial, okay, it is continuous for all real numbers and it will have smooth rounded curves. So it can't have any breaks and it can't be like an absolute value graph, okay? No sharp turns, gaps, holes, then it's not a polynomial graph. Polynomial functions are smooth continuous curves with no breaks or gaps. The highest exponent power is called the degree. We've already talked about this, right? That's review to everybody. Highest exponent power. So if there is no variable, it's just called a constant. If there's a power of x to the first, it's linear. If it has an x squared, it's quadratic. If the highest power is an x cubed, it's cubic. The highest power is 4, it's quartic. So on, beyond cubic, we probably just call it a polynomial of degree 4 or whatever. All right, this is also review. The power and the leading coefficient of the leading term determines the end behavior of the function, okay? So if we have an even degree with a positive leading coefficient, for example, y equals 7 plus x to the fourth. Does everybody understand that this is a leading coefficient of 1 in degree 4, even though it's not written in the right order? Okay. So this would be degree 4, leading coefficient, positive 1. And the shape would be like this, or possibly like this, depending on what's going on. But both ends are up. That's all we need to know. Even degree, negative leading coefficient, like a negative 6x to the fourth plus x squared minus 1, something like that would be both ends down. Odd degree, positive leading coefficient, like y equals x cubed minus 6x plus 2. I'm just making junk up, but the left end is down, right end is up. And depending on the degree, it could have lots more wavy stuff going on in the middle. If it has odd degree with a negative coefficient, like, actually already went, didn't you? Okay, we're all good. It's all good. Negative 2x to the fifth plus blah, 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 blah. Then the left end would be up and the right end could be down, no matter how many loop-de-loop. That can't be pointy. Sorry, that's a bad picture. Let's just erase that. Okay, left end up, right end down. Does that feel like we're comfortable with that already? I hope. That's a big part of the lesson today, okay? The important issues. What is the difference between even and odd degree and even and odd function? Even and odd degree helps determine end behavior, okay? Both ends up, one end down, that kind of thing, okay? Even and odd function is symmetry. Remember this? Okay? Even would be y-axis symmetry, and odd would be origin symmetry. So this one might look like this, and origin symmetry might look like that. Questions? All right, so even or odd power and we're positive or negative leading coefficient. That's all we care about on these graphs. Okay? Both ends are down, so it is even or odd power. Even power. And both ends are down, so the leading coefficient must be negative. Everybody okay? Okay. What's I gonna say? I have no idea. Oh, it's not an even function though, right? It's not perfectly symmetric about the y-axis. All right. Ends are going opposite directions. What does that tell us? Odd power. Odd degree is what they want us to say, I guess. But, oh, they said power up there. Whatever. Normally a cubic does this when it's positive, so left end down, right end up means this one is positive. Everybody good? Positive leading coefficient. And both ends up. Even power or degree with a positive coefficient. Any questions? Okay, you were supposed to do a slide last night. I don't know if anybody actually did them, but one of those slides is to drag some things, the graphs, to the right spot, positive, negative, leading coefficient, etc. Guys, there's exactly one assignment in Google Classroom right now for Unit 2. I've not assigned stuff through Google Classroom, but that's the slides you're supposed to be working on. You were supposed to do, I think, slides 6 and 7 last night, okay? So at some point, I'm not checking them yet, but. So tell me about this one. We're supposed to simply find the degree and leading coefficient and describe the end behavior. What's the degree of this one? Degree means highest exponent power, guys. 4. Leading coefficient in front of that term is a positive 2. So both ends are going to be up. Do you want me to write it in this notation? Means the y is going to be positive both on the left and on the right. Do we need to practice that? Okay, what's the degree on this one? Degree 5 with a leading coefficient of -3. So odd degree, but a negative leading coefficient means it goes this way. You might be doing something in the middle, but left end is up. So y is up on the left and y is down on the right. If you don't want to write the interval, this notation, you want to just draw a sketch so you know what we're talking about, that's okay. I don't really care. It's your notes. Okay. What's happening here? They're trying to trick us. Little stars, because what's the leading coefficient in degree? It's not in standard form, right? So the highest exponent power is still a 4, and the -7 is a leading coefficient, so this would be both ends down. Or y is going to approach -infinity both as x goes left or as x goes right. Any questions? All right, nothing super new yet, right? Feel like you've seen all this before? You good? All right, so review from graph analysis. The points at which a polynomial function switches direction are called turning points, okay? And if the turning point is higher than any other point near it, it's called a relative maximum. The turning point is lower than any point near it, it's called a relative minimum. Maximum and minimum values together are called extrema. So that just means maxes and mins put together. Turning points define the function as increasing or decreasing. where the function is increasing or decreasing changes when you have a turning point. All right, this is the important business over here, and we're going to fill it in down here, but a polynomial function of degree n has at most n distinct zeros, can have less because there could be repeated zeros, we'll talk about that, at most n minus 1 turning points, and also n minus 2 inflection points at most. Okay, so the x-intercepts, how do we find them on our calculator? What's the feature we use? Zeros. Called zeros. Okay, a polynomial function of degree n can have at most n real zeros. An even degree polynomial has an even number of real zeros. This kind of confused me because that includes the multiplicities, and we'll talk about multiplicities in a minute. An odd degree polynomial can have an odd number of real zeros. Is the next slide have that business, or do we need to talk? I think you need to make sure you got this business over here, okay? Degree n, then n minus 1 is the number of turning points. Okay. So if it's a degree 5, the most turning points it can have is 4. That didn't work so well. I held up 4 fingers. Degree 5, maximum number of turning points is 4. So degree 7, maximum number of turning points possible is 6. Everybody okay? And there'd be even one less maximum number of inflection points, but we're not going to spend a lot of time on that. All right. The solutions, when you take a polynomial and set it equal to 0, okay, the zeros are called the solutions or the roots. When we take each of those roots and do x minus that, it becomes a linear factor. So if I had some crazy polynomial, and I had that it had zeros at 7, 1, and negative 1, we'll say, okay? That would mean the factors would be x minus 7, x minus 1, and x plus 1. Does this sound familiar? Does that make sense now, what I'm saying? All right, so linear factors can be found by either factoring the polynomial or possibly graphing and doing some division is what we're going to work on next week. So what can I take out of this guy? I can't hardly read that. I think it says x cubed plus 5x squared minus 24. Is that what it says? So if I take out an x, I have an x squared plus 5x minus 24. And then I would need to factor that. That's not a linear factor, that's a quadratic factor, but I could go further. It would factor x plus 8, x minus 3 to get a positive 5 in the middle. Everybody okay with where I got those? Now, those are linear factors because each power of x that's left is just x to the first. Everybody okay with that? We got it down to linear factors. So if this was set equal to 0, what would the zeros become? You'd have x equals 0, x plus 8 equals 0, and x plus, or minus, 3 equals 0. So you'd get 0, negative 8, and positive 3. Everybody okay? If you graphed it, because it was a positive leading coefficient, it would come from the left. There was a negative 8, a 0, and a 3. So it would come from the left, cross here, and cross here. I don't know how high or low it goes, but that's where the x-intercepts would be, and that's the big chunk of the rest of the lesson. All right, example 2. You have this finished for you, so let me just talk you through it. If we grouped those first 2 and the second 2, out of the first 2 I could take an x squared, so I have left an x plus 2. What can I take out of these back two so that I will also get a parenthesis of x plus 2? Because when you group, they have to be the same. I can take out a negative 1. Then if I take this factor out of each, there's left an x squared and a minus 1. Then this factors as the difference of squares, x plus 1 and x minus 1. So I have a negative 2, a negative 1, and a 1 that are the zeros. Okay? And the linear factors were these right here. All right, so we're going to practice some stuff here. This is degree what? Degree 4. So the number of possible zeros is 4, and the number of possible turning points is 3, because it's n minus 1, degree minus 1. Let's do that part on 4b, and then we'll come back and do the other part. What is the degree of this one? This is degree 5, so the number of possible real zeros is 5, and the number of possible turning points is, everybody get that? So zeros equals degree, and turning points equals degree minus 1. Okay. To factor, remember the fancy factoring we did? Anybody remember how you factor an x to the 4th and an x squared? X squared and x squared, factors of 18 that would make a minus 9. Negative 6 and negative 3. Okay, now it wants the zeros, so we have to set each of those equal to 0. They don't factor further. If we add 6, we get x squared equals 6. This one would become x squared equals 3. Then what? It's not pretty zeros, but they're real. What are... How many are we supposed to maybe have? 4, right? Does anybody know what the 4 are? Positive square root of 6, negative square root of 6. Remember when you square root an x squared, you have to do plus or minus? And when we square root this guy, we get positive square root of 3 and negative square root of 3. Now, we won't always have 4 distinct different zeros, but there are on that one. What can we do on 4b? Take out an x, that'll leave x to the 4th minus 6x squared minus 16. Oh, fabulous. We got an x out here. But this still factors how? X squared and x squared, because we have an x to the 4th and an x squared. Okay, factors of 16 that make 6. Negative 6 would be negative 8 and positive 2. All right, so if I set x equal to 0, I get 0 as one of my roots. If I get x squared minus 8 equals 0, I get x squared equals 8, or plus or minus square root of 8. Anybody know what that breaks down to? Square root of 4 times square root of 2, which would be 2 square roots of 2. So we'd have positive 2 square roots of 2, negative 2 square roots of 2. And back here we get x squared plus 2 equals 0, x squared equals negative 2. What happens there? Can you square root a negative 2? Only if you want imaginary answers. This said real zeros, so these don't work. Okay? So this had only 3 real zeros. Okay, again, not really new concepts, right? Just connecting some old ones together here. We're just going to skip this one for time's sake. We could do it as a warm-up tomorrow, maybe Monday. All right. This says this is really kind of what we were talking about before, but it's going to introduce this word multiplicity. If x minus c to the m, so if we had like x minus 3 squared, is the highest power of x minus c that is a polynomial function, then c has a 0 of multiplicity m. So we would say here there's a 0 at 3, and we'd say it's multiplicity 2. The exponent on it is 2. If the has an odd multiplicity, then the graph crosses the x-axis. If it has an even multiplicity, then the graph is tangent to the x-axis, or we say it bounces off the x-axis or kisses. Does anybody remember this from last year? So if you had a polynomial like this, anybody know what degree that would be? This is an x, this would be an x that's been squared, right? And this would be an x that's been squared. I'm ignoring all the other terms. This is called the leading coefficient test. But I'm ignoring all the other terms, but the x's, when I squared them, I get how many of them? An x to the 5th. Everybody okay? So this has a multiplicity 2, and a 1 out here. So it's degree 5. So it looks like this. But the fact that this is a 0 of multiplicity 2 and this is a 0 of multiplicity 2, we're going to spend more time on this, so you don't have to copy this example necessarily, but at 3 and at -2 and at 0, it has zeros. What it does, though, because this is squared, is it bounces here, and then it comes back and crosses, and then it bounces here, because that one is squared as well. Let me explain it this way. Right near -2, right here, it's almost like a little baby parabola right in there. See that? Because it's degree 2. And over here at 3, right here, it's like a little baby parabola. It bounces off there because it's degree 2. Now do you remember a little bit of this from Algebra 2? Okay. It says find the multiplicity of a 0 and its corresponding linear factor. So this number 7, what can we take out of all those? Is that a degree 3? So we can just take out an x, and that would be x squared plus 10x plus 25, which factors x plus 5 times x plus 5. Whoops. I don't know why I wrote a 1. I'm going to erase this. So we can write this as x times x plus 5 quantities squared. So the zeros are 0 and -5, but what do we write by the -5? It's called multiplicity 2 because it had a 2 exponent. And if we were to graph it, it's a odd degree with a positive leading coefficient, so it comes from here, but at -5 it's going to bounce and then it's going to cross at 0. I'm going to spend more time on that in a minute. All right, what can I take out of all these? I would take a negative and an x squared out maybe. That would leave x squared minus a 6x plus 9. Did that work? Which factors x minus 3 and x minus 3. So we can write negative x squared and x minus 3 squared. So where are the zeros at? 0 and 3, and both of them are what? Because they're squared, we write multiplicity 2 on both of them. So there's a total of 4, which was a degree 4, okay? This one had a 0 and a multiplicity 2 here. So 1 multiplicity and 2 is a total of 3. By the way, this one was degree 4, so both ends, and negative leading coefficient, both ends would be down. So it would bounce at 0 and then again bounce at 3. All right, now they're going to finally tell us that. It says graph x cubed plus 4x squared plus 4. If we take out an x, that factors x squared plus 4x plus 4, which factors x, x plus 2, and x plus 2. Or x and x plus 2 squared is the factored form. So it has a 0 at 0. And where's the other one? Be careful. Negative 2, right? And that one is multiplicity 2. So it has a 0 at negative 2 and a 0 at 0. It is a degree 3 that we started with a positive leading coefficient. So the shape should be like this. So which one is it going to bounce off of? At negative 2, okay, it's going to come from down here, and at negative 2, because of the multiplicity 2, it's going to do a little baby parabola shape, where it's going to touch and turn around. It has a turning point at negative 2. And then I don't know where, but at some point it turns around because it crosses at 0. If the multiplicity is even, the graph is tangent to or bounces off of the x-axis. If the multiplicity is odd, the graph intersects the x-axis or crosses. I graphed it on the calculator. This is what we got. Okay? I'm not taking your calculator away, but you have to understand this vocabulary and how it's supposed to help you graph. The other thing is, when we struggle with a window, we sometimes can't see if the whole graph is there, right? If we know what it's supposed to do out on the ends, that helps us tell whether we can see the whole graph. All right, you got that or not? Need more time on that slide? All right, let's practice. So what are the zeros here? This is nicely factored. So we have a 0 at 1, yes? X minus 1 equals 0 makes x equals 1. Okay, this one we got to do a little work. 2x minus 3 equals 0 would mean x equals 3, and then we'd add 3 and then divide by 2. Everybody okay? I didn't show all my work. And back here, if we did x plus 4 equals 0, we'd get negative 4. Okay. What are the multiplicities on those? This 1 came from here, and what was the power there? 2. This 3 halves was from here, and that had a power of 2. But the 4, the negative 4, came from this factor, which didn't have anything, so it's a power of 1. Okay, even multiplicity means it bounces. So this is going to bounce or turn around and have a turning point at 1. Also at 3 halves or 1 1/2, it's going to bounce or be tangent to the x-axis. It's going to turn around and have a turning point there. But at negative 4, because the multiplicity 1, it's actually going to cross the x-axis. All right, they didn't factor this one for us. What can I take out of all those? An x squared, that'll be an x cubed plus 8x. Wait a minute. Oh, is that a 3 and less? I'm like, we're not going to be able to factor this. What did I do wrong? Sorry. I thought that was a 2 on the last one. I can't read it very well. So it started out x to the 5th plus 8x to the 4th plus 16x cubed. So we can take an x cubed out. Thank you. x squared plus 8x plus 16. How does that factor? Factors of 16 that make 8. X plus 4 and x plus 4. So we have two factors the same, or an x plus 4 squared. So where are the zeros at? 0, and that one is multiplicity or power of 3. Now that's an odd power, so what is it going to do there? It's going to cross. It actually would do a funky little cubic shape like that right there, but it will cross. All right, and then let's see, I'll do in blue. What is that guy going to do? Has a 0 at -4. Multiplicity is power of 2, and an even means it's going to bounce. Just again, for your information, this was a degree 5 with a positive leading coefficient, so it's got to start from down here somewhere. We had a 0 at -4 and at 0. At -4, we said it was going to bounce, so it would come from here, bounce, and then at 0, it would cross. It would probably do this little goofy thing like that. All right. This is the leading term test business. I have a -2 times an x. Here I have another x, and back here I have a 3x that's to the third. I'm ignoring anything that's not an x, okay, for just a minute. So this is a -2 times an x times an x times a, what would this be? What's 3 to the third, guys? 27 maybe? And then an x cubed. I really only care that the leading term is negative, yes? 2 and 27 is like a -54, but it has a negative leading term. And what degree is it? If there was an x here, an x here, and an x third back here, that is degree 5. All right, determine the zeros. So if I set that first factor equal to 0, or the second factor equal to 0, or the third factor equal to 0, this one just comes out 0. This one comes out 4. Whoops, this is supposed to be 0, sorry. Add 1, divide by 3, and I get 1/3. All right, what was the power on the first one? This -2x just had a power of 1, right? So we could write multiplicity 1, or we could just not worry about it. X minus 4 also had no degree, so it's multiplicity 1, or don't worry about it. But this guy at the back had a multiplicity 3. If you add up the multiplicities, they should add up to the degree. Multiplicity 3, multiplicity 1, degree 5. Everybody okay? All right, what did we do so far? We did part A, part B, and then it says draw a rough sketch. Degree 5, leading coefficient negative. Oh. Odd degree means the ends are going opposite directions. But where's the negative going to tell us it starts? Yeah, from the top down. It's going to be doing something like this, okay? So now we're going to do a sketch by putting the zeros on. It had one at 0. It one at 1/3. And one over here at 4. I have no scale. I don't care. Just so I have them all. It's supposed to come from the top. What is it supposed to do? They're multiplicity 1, and multiplicity 3. Any bouncing? They're all odd, so it's going to cross. At 1/3, it would cross. It might do a little goofiness there, but that's okay. And then at 4, it would cross. So that's a horrible graph. Let me try again. 0, 1/3, 4. Should be coming from the bottom, doing a little goofiness. Okay, it doesn't matter. I have no idea how high it goes. It could go way high, go down way low. It doesn't matter. That's just the general shape. All right, how much time do I have left? Okay. I think this is the last one we're going to do today, maybe. Take out what here? Well, first of all, yeah, I'm going to take out a negative x. But first of all, what it's already in a way we can tell the leading coefficient in degree, yes? The degree is 3, the leading coefficient, anybody? -1. So the shape is again going to be like this, right? Degree 3, negative leading coefficient from the top on the left. Okay. Now if I take out a negative x, I have an x squared minus 2 and an x minus 8. So we have a negative x. This factor is x minus 4, x plus 2. Those of you who struggle with factoring, are you getting the idea yet that it's going to be painful here if we don't get this? All right, so where are the zeros at? 0, 4, and -2. Any of those have a multiplicity other than 1? No, they're all multiplicity 1, right? So that means it crosses at all those places. You got to put them on there in order. -2 is to the left, 0 is in the middle, 4 would be over here somewhere. But it's coming from where? Top left. So cross, cross, cross. Now, if you graph that on your calculator, it's likely to go whip it up really high where I just did a little bump. But again, my y has no scale. This could be 100 right here, right? Doesn't matter. Okay. We have time to do this last one? Yeah, let's go with it. Because this is the kind... Okay, it has a negative x, but the leading coefficient here, this is a 2x that is squared. And then on the back, there's an x. This is called the leading coefficient test because I'm only looking at the x's, okay? What's going to happen? How many x's am I going to have? An x squared, and an x is a total of degree 4. Okay, if I square this, I get a 4, but it really doesn't matter. All I care is that it's going to turn out, because of that negative in the front, to have a negative leading coefficient, guys. I don't really care what the leading coefficient is. I just know it's negative. So what is it going to look like if we have a degree 4 with a negative leading coefficient? Degree 4, both ends go in the same way. Negative means both ends down. All right, where are the zeros? We have a negative x, a 2x plus 5, and an x minus 3. So this one has a 0 at 0. Multiplicity 1. What about that guy? Can you set that equal to 0 and solve in your head yet? Negative 5 halves. Multiplicity what though? 2. People say, I don't understand multiplicity. It's just the power of the 0, okay? If it's got a squared on the whole thing, then it's multiplicity 2. If it had a 3 on the whole thing, it's multiplicity 3. What you have to know about the multiplicity is that if it's even, it's a what? Bounce or a tangent or a kiss. Some people say it kisses the x-axis rather than actually crosses it. This one, if we set equal to 0, we get 3, and that's multiplicity 1. Okay, tell me those left to right. Where do I want to plot those on here? Negative 5 halves is a negative 2.5. Then a 0, and then a positive 3. Okay, both ends we decided are down, so it's going to come from down. What's it going to do at 5 halves? This is the only one where it bounces because it was a multiplicity 2. So it's bounce, cross, cross, so that both ends are down. Okay, I know it was a lot of notes and a lot of examples, but how do you feel? Seems a little okay? All right, so the assignment is Delta Math 2.2 Part 1 Polynomials. Please do the practice, okay? This is not a concept because we're going to build on this and it's going to get more complicated. So it's not a time to go, yeah, I think I get it. Okay, do the practice and do it this weekend so that when we build on it next week. All right, Monday, we have an activity in Desmos. Did anybody ever do anything in Desmos in a math class before? It's just a little tiny game. They're going to give us a bunch of polynomials and you're going to say to your partner, like, does it have a even multiplicity at the 0 of 5? And you're going to say, no, it doesn't. It's like Guess Who? Did you ever play Guess Who? Where like